Hello students, today we are going to be learning about box plots. A box plot is a way of visualizing a data set. It shows 5 important values for your data set: the minimum, the lower quartile, the median, the upper quartile, and the maximum. Let's take a closer look at each of those terms. The minimum is the lowest value in your data set. In this example, the minimum is 1. That means the lowest value in this data set is 1. The maximum is the highest value in your data set. In this example, the maximum is 10. That means the highest value in this data set is 10. The median is the middle number in your data set. In this example, the median is 5.5. 1/2 or 50% of the values in your data set are above the median, and 50% are below. The lower quartile, often called Q1, is the median of the lower half of your data. That means 1/4 or 25% of the data is below this value, and 75% of the data is above this value. The upper quartile, often called Q3, is the median of the upper half of your data. That means 1/4 or 25% of the data is above this value, and 75% of the data is below. Let's take another look at this box plot. Another name for a box plot is a box and whisker plot. You can see the box in the middle. The left edge of the box is the lower quartile. The line inside the box is the median, and the right edge of the box is the upper quartile. The whiskers are these lines that extend from the quartiles to the minimum and maximum values. You can also calculate other measurements from a box plot. The range is the difference between the maximum and minimum values. It's a way to measure the total spread of the data set. With this data, we need to take 10 minus 1, so the range is 9. The distance from the lowest value to the highest value is 9. The interquartile range, also known as IQR, is the difference between the upper quartile and lower quartile values. It's a way to measure the middle 50% of the data. With this data, we need to take 8 minus 3, so the interquartile range is 5. So what does the IQR range actually tell us? Let's find out. The interquartile range is a way to measure the variability of your data. If one data set has a larger quartile range than the other, you would say it has more variation, which means the values are more spread out. I think we're ready for some real-world problems, so let's go. Sarah works at a daycare facility for a summer job. She keeps track of the number of hours she works each week. This box plot shows her data. What percent of the values are less than 33? First, let's find 33 on the box plot. It looks like 33 is on the left edge of the box. That's the lower quartile, which means 25% of the values would be less than 33. So the answer is 25%. Let's try another question with this data set. What's the range of Sarah's data? Range can be found by subtracting the minimum from the maximum. The maximum value is 41. The minimum value is 29. 41 minus 29 is 12. The time Sarah works on a weekly basis ranges by 12 hours. Let's try an example comparing two box plots. Students record how many questions are on their homework assignments in both their math and science classes. These box plots show the results. Which class has a higher median? The median of a box plot is the line on the inside of the box. The math class has a median of 14, while the science class's median falls on 16. So the science class has a higher median. Which class has a lower range of questions? Range is maximum minus minimum. The minimum of the math class is 10, the max is 20. If we subtract 20 minus 10, we get 10 for the range. The minimum of the science class is 9, the maximum is 21. If we subtract 21 minus 9, we get 12 for the range. The math class has a lower range, which means the number of questions on math homework varied less compared to the number of questions on science homework. In conclusion, be sure to take your time identifying the minimum, maximum, median, and the quartiles. Most box plot questions involve those 5 values. Thanks for watching and good luck with box plots.